take this off. Is that okay?
Yeah.
Who wrote this? We account the scriptures of God to be the most sublime philosophy. I find more sure works of authenticity in the Bible than in any profane history whatever.
Augustine.
Where do I
How
get
about
one?
Randy, what did you say?
I just guessed Darwin.
Darwin? No.
Augustine.
But he's a famous man.
Augustine.
Bacon.
Somebody over here?
Answer this one.
Sir Isaac Newton.
I had a surge.
And, he's the one that made the mathematical expression to God's law of gravity. Sometimes we say it's Newton's law of gravitation.
Of course.
But it's God's law, and Newton put numbers to it so we could calculate it. But I thought that's very cool that a man that we all know the name of could say something as encouraging as that about God. Very cool. So the homework, I asked you, what objections could someone raise against an age for the earth that is less than 10,000 years? Or put it another way, it could not be so because, and have you had some chance to think about that? And what is it that you have either heard from people or maybe yourself, you thought the earth can't be that young, it must be older than that? Yes, sir?
The fossil record.
Good, the fossil record. Yeah, the age of the dinosaurs, clearly more than a few thousand years ago. We're going to talk about that tonight, so I'm going to wait and cover that, but that is a really important one, right? Fossils are supposed to be older than that. At least many fossils are thought to be. What else might be? Yes, Liz?
Because of evolution. It takes longer for all these things to evolve from
That's right. Evolution takes time, right?
whatever it is they think it comes from.
Yeah, that's right. We're going to talk about that tonight too. That's good. We're on the same wavelength. That's God. That's awesome.
The speed of light.
Anything else? Oh, the speed of light? Did I hear that? We're going to talk about that too. The speed of light. Cool.
The rate of radiation decay.
Radioactive decay, okay? That it takes longer to decay than...
Well, the whatever the rate is now, they use to say that things couldn't have the age that.
Oh yeah, you're right. Okay. The dating techniques that use radioactive elements tend to date the Earth very old because they have no choice but to do that, and we'll see how that works tonight. Yeah. They couldn't date a young Earth with that method if their life depended on it. Rebecca?
Maybe that most scientists don't believe in that. So they, you know what I mean? So there's more people that are on the other side of it being a longer time, then there's maybe some credibility to that.
Oh, Rebecca raised a really good point. You know what Paul said? The natural man thinks the things of God are foolishness. So if you think the earth is young, it tends to like, oh, you're one of those Bible thumper people, right? So, right there you're discounted as a lunatic, right? You're nuts. Or you're uneducated for believing such a thing, because there's so much out there that's contrary to that.
Or at least you're in the minority of thinking of it.
You're in the minority, yeah. Cool. Anything else we haven't mentioned?
Is the gap theory?
The gap theory?
Yeah.
Okay, good. Yeah, that's not, I didn't have that in our notes for tonight, so let me just say a few words about it. The gap theory says that there was a gap of time between Genesis 1:1 and Genesis 1:2. That the word bara, which means to create, can be taken as recreate. Okay? So in the beginning, God created the heavens and the earth. The thinking that if there was a recreation, then there was a previous creation that was demolished in, and I've heard various people say different things, but like Lucifer's flood demolished that first creation, and then so we're talking in the Bible about a recreation. And that puts all the fossils back before in time and explains them all, not with the flood of Noah, but with Lucifer's flood. And so I don't think there's a whole lot of evidence for that, but people do bring that up, the gap theory. Yeah, that would add lots and lots of time to the whole thing by having a gap between Genesis 1:1 and 1:2. Yeah. Anything else we haven't covered? Okay, cool. Last time we met, we were talking about glorifying the Lord in whatever we think, however we think the age of the earth is. Certainly God was here, He made the earth, He knows how old it is. But if we have a method of dating the earth that doesn't glorify God, we're missing the point that God is the creator of the earth, and we should glorify Him for doing that. And so it's not so much the number of years that you come up with, but what method do you use? Is it a method that glorifies God or not? So the method that we went through last week was adding up the genealogies, basically, to come up with an age of the earth that Bishop Ussher came up with about a 6,000-year-old earth. So tonight, what I'd like to do is to talk about some objections to the young earth, and then we're going to go into dating methods that are thought of by people that are not scriptural at all, but they give us different ages, and we'll talk about the limitations and the assumptions of those things. So I'm going to be, and the page numbers are in the upper right corner of each page. So it's got page something of 17. And I had one page that I forgot to include, so I had to put 14B after 14 and before 15. So we'll see that page is kind of loose in there, but we'll cover that. And my friend here, Rodin's The Thinker, whenever you see that on a page, there's something to write down or to take a note on if you want to take notes. There's something there whenever you see that little sketch there. Okay. All right. So I've said here that near the top of page 1, that according to dictionary.com, an opinion is a belief or a judgment that rests on grounds insufficient to produce complete certainty. All the age dating methods have some unknowns to them. And so we're going to have to do some assumptions, some clever thinking to try to figure out how can we take a method and get an answer to it if we don't know everything. And we just don't know everything. We don't at all. I tell my students, I say, if all we know about the earth is as long as a yardstick, right in front of the classroom, if all we know about the earth is 3 feet long, how much of all we know, of all there is to know, do we now know? Okay, so if all there is to know about the earth is the yardstick, how much of all there is to know do we now know? Is it like a 1 inch of the yardstick? Is it 1 foot of the 3 feet of the yardstick? Is it 2/3 of the yardstick? Or is it all of the yardstick? Well, clearly, we don't know all there is to know because we're discovering new things all the time. Like Scientific American and Smithsonian, they report new things that people discover. So we don't know all of it right now, but how much do we know of all there is to know? Right? And we don't know, because if we don't know how much we know, if we don't know how much we don't know, we don't know how much we do know, so we really may not know much at all, right? But here's how people think. They make a discovery, they make a conclusion from it, and that conclusion is only good until a new discovery is made that either supports it or rejects it. So we're constantly making adjustments to the body of knowledge that we think we know, but we don't know all of it. God does, but we don't. Okay? And so there are some assumptions with this using the genealogies in the Bible. We have to assume that a son of someone was either the son or the grandson or the great-great-grandson, right? We don't know if we have all of those correct. Because if we don't have, if we think it's a great-great-grandson and not the son, that will affect our time of the earth. Because we're adding up all the genealogies to get back to the time Adam was made. And then we have to add 5 days onto that because Adam was made on day 6 and the earth was made on day 1, so you add 5 days. And so we have to assume that those are literal days, or if you don't think they're literal days, whatever long you think they are, we have to be clear as to what that is. And then finally, that the Bible is fact. It's not a fiction book, not made up by somebody. So there are some assumptions with what we did last week. And as you'll see, there's going to be some assumptions in all of these dating methods we're going to talk about tonight. So the whole idea of starlight being so long in its transit in space, much longer than the age of the earth, is an objection. And so I'm going to read here near the bottom of the first page. It's from a website that clearly describes this problem, this objection to a young earth. So it's the italics there near second paragraph from the bottom. It says, a light year is the maximum distance that light can travel in 1 year in the vacuum of space. Consequently, it takes billions of years for light to travel billions of light years through space. From our vantage point here on Earth, we can see light from stars that are billions of light years away. It's reasonable, therefore, to assume that our universe is at least billions of years old enough to give the light from these stars enough time to reach our planet billions of light years away. Does anybody need more explanation than that? Does that idea make sense to y'all? Light's supposed to take so long to get here that the light wouldn't be here if all we're waiting is 10,000 years. We really have to wait billions of years to get for the light to get here. Right? And so there's a bunch of publications that deal with this. At the bottom of the page, I've included a cover to a book, Starlight and Time by Humphreys. That same web page I just read from has another solution, gravitational time dilation. And those two sources, the engineers in this group can read and understand, right? But if you're not an engineer, I don't want to leave anybody in the dust because there's some mathematics involved with both of those. So let's just do cause and effect. The cause and effect argument I like because you don't need any math for it. So if you'll turn to page 2, we're going to go through a solution to this problem, a non-mathematical solution. And to do this, we need to really review how God deals with time. So I'm going to read the paragraph there from from the website that I just read from. It goes on to say, how does God deal with time? And this is important. So on page 2, I'm reading this. God created time as part of this universe to mark the passing of seasons and years for us. But he is not subject to time. In the New Testament, he describes himself as the Alpha and Omega, the beginning and the end. Alpha is the beginning letter of the Greek alphabet, and Omega is the last. In the Old Testament, the Lord describes himself as the first and the last. God is saying that he is always present at all times. There is no past or future with God. Everything is as though it were occurring right now. That's hard for us to comprehend since we are so bound by time. When God identified himself to Moses for the first time, he said that his name was, I am who I am. From those Hebrew words, we extract more familiar name for God, Yahweh. By saying that his name was I am, God was teaching Moses that he was incomparable to any other. He is above, beyond, and all-encompassing. Time cannot confine or define God. In revealing his name, God made a statement of his own self-sufficiency, self-existence, and immediate presence. Now, you may not find that personally exactly the way that you would describe it, but I thought it was a pretty comprehensive way to kind of see God and how he may deal with time. He certainly is not limited by time. And so here's the reasoning for this non-mathematical cause and effect solution. If you read Genesis 1 at the bottom of the page, 11 through 13, and I'll just read the bold printed parts of those verses. It says, let the earth sprout vegetation, plants yielding seed, and fruit trees on the earth bearing fruit after their kind with seeds in them. And it was so. The earth brought forth vegetation, plants yielding seed after their kind, and trees bearing fruit with seed in them after their kind. And so then it ends with evening and morning the third day. So there's a statement there about plants. And notice that the plants are mature plants. Although they may sprout from the earth, in that one day, they came with complete, as though they were mature. They had seeds and they had fruit. Right? And then look at the creation of man on the next page, page 3. I'll read the bold printing there on that paragraph. God said to them, be fruitful and multiply. Fill the earth and subdue it, and rule over the fish of the sea, and over the birds of the sky, and over every living thing that moves on the earth. And God said, behold, I've given you every plant yielding seed that is on the surface of all the earth, and every tree which has fruit yielding seed. It shall be food for you, and for every beast of the earth, and to every bird of the sky, and to everything that moves on the earth. which has life. I've given every green plant for food, and it was so. God saw all that he had made, and behold, it was very good. And there was evening and there was morning, the sixth day. So in creation, God says, you are vegetarians, basically, right? And it's not until after the flood that he said you can eat meat. Okay? Now, God demonstrates his mastery over time by creating seeds which sprout and grow into mature plants all within the third day. If you believe he planted them, they grew to maturity all in one day, I think that's pretty impressive. Or you may think that he just made them mature and didn't plant them and allowed them to grow to maturity in one day. But remember, he's not limited by time. We also read that Adam and Eve were created with age. Okay? God did not make baby Adam or baby Eve, right? He made them as adults. And so the question comes, why? Okay? Why is it that God made plants mature? Why did he make Adam and Eve mature? And I think it was because they had intended purposes that they could accomplish only if they're mature. Can you imagine telling a baby, go be fruitful and multiply, right? Or, gee, the seed is in the ground. How long am I going to have to wait to eat something, right? Like that. Okay, so I've asked some questions here on the bottom of page 3. From these passages, if the Lord had accelerated the growth of seeds into mature plants, would God's intentions for plants be achieved? Remember, the intention was it's food, right? And I think the answer would be what? Yeah, if he didn't accelerate the plant to have seeds and fruit, there would be nothing to eat. Right? If all we had were seeds, that wouldn't be good. And then from the passages that we just read, what did he direct Adam and Eve to do? To be fruitful and multiply, to subdue the earth, right? And you really can't do that if you're a baby, right? So he made them adults. If he had created infants instead of mature adults, would God's intentions for Adam and Eve be achieved? And I would have to believe a baby's not able to do those things, right? And for extra credit, the bonus question is, did Adam and Eve have belly buttons? Now, in our line of thinking the way we've been thinking about things, give me a reason why perhaps they would not have had belly buttons.
They weren't tied to an umbilical cord.
They had no umbilical cord. Good. That's cool. That's
But
cool.
if they had belly buttons, did God have a belly button? Because
What?
we're created it.
I'm sorry,
If they have belly buttons, does that mean God has a belly button? Because we're created in the image of God.
In his image, right. But did the belly button image fall in the image of God? Right? I don't know. Good question. I wrote this tongue-in-cheek to kind of think about this a bit. Now, is there a function to a belly button that you would be really deficient in if you didn't have one?
Yes.
If you were, not if you were created, but if you were born, yes.
The doctor is speaking. This is cool. Okay, good. Yeah. Okay, so there's a purpose for a belly button, right? Okay. Was it one of God's intentions that he would need a belly button on Adam or Eve? I can't think of one. Okay. So I just threw that in there just for fun. Okay, but what does this have to do with starlight? Right? You might be wondering, who cares? Okay, listen to this. Turn to page 4, at the top of page 4. As far as stars go, for what purposes were they created? Right? Weren't they created for a purpose that would involve your eyes? If you could not see them, you wouldn't know they're there. Right? Okay? So since they can only be sensed by our eyes, starlight must reach Earth from them to be noticed at all. So the purpose of stars is very much tied to our eyes, right? Therefore, like the plants and like Adam and Eve, the stars were created with light reaching the earth so that they could accomplish God's purposes for the star. Right? Just as God made plants mature so they could be eaten, made Adam and Eve mature so they could understand the directive to them and accomplish it, I believe that starlight was made by God to reach the earth so that, instantly, so that it could accomplish its purpose. He could see the stars. And keep in mind that, the speed of anything, when they talk about the speed of light being so much, the speed of anything is distance divided by time. If you're outside of time and you're not bound by time, then any distance divided by 0 is infinite. If God is the one calling the shots on light and wants light to be here, he has the credentials to have it happen instantly. It's not that God is dependent on the properties of light that he made, right? When you think about this, it's kind of like God is in control. And if God's in control, he can have light come at any time. And so I tried to avoid the math and kind of deal with it from a cause and perspective idea. If God is who God says he is, he can make light come to the earth to fulfill the purpose of stars. If you don't see them, you don't even know that they're there. Does that make sense?
Yes.
Okay, cool. Simply stated, I tried to make this succinct so it's like one statement. Every effect that God intends is produced by a sufficient cause. So our omnipotent and omniscient God is not limited in his ability to execute every minute detail of his intent. He is certainly able to do all of it, right? And that passage in Isaiah there in the middle of page 4, not one of the stars is missing. It's kind of awesome to think about that, right? We look up there and say, I wonder how many are gone, right? God says not one of them is missing, right? What an awesome thing to say. But there's more to this, which is really cool. At the bottom of the page, look at all those verses. They all speak of how God made the heavens, and with the stars, he stretched out the heavens. All those verses have the word stretched in them. Okay? Like the one at the bottom of the page, it says, "It is he who made the earth by his power, who established the world by his wisdom, and by his understanding he has stretched out the heavens." Okay, a good question is, why is it described as stretched out? In one of these verses it says, like a tent. If you have a tent, Randy just got a new tent, is that right? You stretch it out, where you take it out of your pack, you have to kind of make it larger than it was, right? Okay. Am I right? Did I get that right? You just got a new tent? Okay. Okay. So, it turns out that if you stretch out space, the galaxies in space fulfill a law called the Hubble law, which means the farther away a galaxy is apparently away from us, the faster it's going away. So if we know the distance to a galaxy, and a galaxy is a group of stars, if we know the distance, we can estimate the speed. The farther away they are, the faster they're going away. It's called the Hubble law. Not all galaxies do this, but most of them do. So I've said usually they are receding from us, the farther away ones are receding from us faster than nearby galaxies. Anything that expands will do this. It doesn't have to be space. It doesn't have to be a big bang. It could be God stretching things to make the stars. And in fact, anything that we can blow up a balloon and do that, but we can also bake a raisin cake in the kitchen and see the very same thing. So look at this sketch of the raisin cake. This is a raisin cake that sits for an hour and gets bigger. It doubles in size, and it's got a bunch of well-placed raisins inside. All of those letters are raisins, and all the numbers are inches apart from one of the raisins. Raisin A, we're measuring from raisin A. So notice that from A to B is 1 inch in the small cake before it grows and gets bigger with the yeast in it. From A to C, if you look carefully, it's very small. From A to C is 2 inches. A to D is 3 inches. A to E is 4 inches, and A to F is 5 inches. So let's say that the yeast is working. After an hour, the whole cake doubles. So now look at the distances. From A to B is now double. It's now 2 inches instead of 1 inch. All those distances double because the whole cake got twice as big. So, like an engineer, like Bill would do, Bill Locos over here, he'd look at this and say, I can calculate something. or Randy did, right? He'd say, well, B, looking now at the words to the right of the sketch, B is increased from 1 inch to 2 inches in 1 hour, so it's moving at a whopping 1 inch per hour. That's fast for a raisin, in case you're wondering. Now C was 2 inches, and it turned into 4 inches in 1 hour, so it's moving twice as fast at 2 inches per hour. D was 3, and then it turned into 6, And so that's 3 inches per hour. E goes from 4 to 8, so it's 4 inches per hour, and F travels the fastest of all the raisins at 5 inches per hour. Right? If something is doubling in its volume, the farther away something is in that volume, the faster it's moving away from anything else. It doesn't have to be a particular place. It's called the Hubble law. Now, how is it explained with real galaxies? It's explained by a Big Bang. What could cause everything to get bigger in space? It's not yeast that works in the kitchen, but it doesn't work in space. Right? So there was an explosion, of course. What kind of explosion? A big explosion that caused all the galaxies to be rushing away, space forming in between them, such that the farthest galaxy is moving away the fastest. And that's supposed to be one of the big pieces of evidence for the Big Bang. But you can bake a raisin cake and come up with the same thing, or you can take those verses from the Bible and come up with the same thing, right? Right? If you stretch these things in space, the farther away one would be moving away the fastest. That works with anything that stretches, which is pretty cool. It's either a great coincidence or God really put down something that we could grasp in our modern day thinking. Okay, so here are some dating methods now I want to go through that are not scriptural. Okay, these are methods that get the earth, and they all have uncertainties, just like the biblical genealogies do. And so when we are met with an unknown, we have to come up with an assumption to put something in there, whether it's a quality or a number, so that we can make sense out of this. When I taught at the college and people questioned my way of teaching because I taught them how to think, not what to think, like if they thought the age of the earth was 6,000 years, as long as they could defend it, I gave them credit for it, which bugged the heck out of most of my colleagues because they're looking for what the multiple choice question would be, the earth is, and like that. So typically if it was a science person criticizing me, they would say there are no assumptions with these methods. No assumptions. Or they'd say the assumptions are insignificant to even consider. Or if it was an administrator talking to me and saying, you can't teach how to think, you have to teach what the book says, what the textbook says. So they don't even deal with science, they dealt with, you have to teach the facts that are in the textbook and nothing more than that. So that verse at the bottom of the page I think is appropriate. In Proverbs, the first to plead his case seems right until another comes and examines him. And if you don't let another person come examine him, then you deserve to get stuck where you are. I think it's good to be examining everything. Einstein said, question everything, always question. In fact, when Einstein was given a problem to solve for an hour, he said he would ask himself questions for 50 minutes. And only in the last 10 minutes would he formulate an answer to the question, because he just valued questions. Questions are very good. So now we're on page 6. Why fossils are associated with an old Earth. Or you could say dinosaurs. They lived millions of years ago during the dinosaur age. Right? So just in case you're wondering where I learned that, I was a great fan of the Golden Book Encyclopedia. This is actually mine. I do keep a few things, right, Sharon? I lost my... Well, it does say in here that dinosaurs lived millions of years ago, so I believed everything. I won't take the time to find it, but it's in the encyclopedia. This I bought for... because I like the pop-outs. And it says, dinosaurs lived millions of years ago, long before there were any people on Earth. So there you go. And so we're trying to convince the young people that science leads us to think dinosaurs are old. And this is not for kids. This is Arizona highways, 1951. Good year. I was born in that year. And there's a picture in here of Grand Canyon. It's Havasupai Canyon, and it's got some pictographs. As the rock ages, it develops a dark patina on the outside from the erosion of the air with the minerals. And so some intelligent men, women, lived in the past, took other rocks and just pounded on them to expose the light-colored rocks below the patina. Right? So you can see some white little things on this picture. Right? And one of them looks very strange. It doesn't look like a living thing that's on the earth today, except unless you want to think it's a kangaroo. But it says, what did some prehistoric man, let's see, when did some prehistoric man make this pictograph, because you're pecking at it, on the canyon walls of Supai? Did he actually see a dinosaur? Question mark. Science says dinosaurs vanished from the earth before modern man appeared. Okay. So there you go. It's all over the place. We are, I call it brainwashing. We are brainwashed into thinking certain things. And in fact, we're brainwashed into thinking that all of Earth history can be shown in a sketch, like on page 6. And that's a sketch that's in all science, pretty much all science books. Here's another one. It shows all of Earth history from the oldest at the bottom to the youngest at the top, and ages and different life forms that are supposed to be in the fossil record. Okay. Right. So a really good place to start looking at this to see how realistic it is to ask yourself a really good question. How come it's never a photograph? Never a photograph. It's always a sketch or a diagram, but it's never a photograph. And that's because it does not exist in one place on the earth. It's pieced together from place to place to place with some assumptions. Right? See, all of these layers don't exist in one place where one is below or above another, but when you piece them together, they are. So let's just see how this diagram was put together. Now, when you drive to Los Angeles, do you see layered rocks? These layered rocks are called sedimentary, like Vasquez rocks, right? So you see them, but do you see them everywhere on the drive or just in certain places? Just in certain places, right? Okay. So if you just slow down to 80 next time you go by Vasquez rocks. But today people drive so fast. Just slow down so you can see, you can look out without crashing your car, that those layers have rocks in them. Some of them are the size of this table, but many of the rocks are small. Okay? But Vasquez rocks appears and then disappears as you drive along. Because there are other rocks that are on each side of it, or the rocks have been eroded. Even the top of Vasquez rocks is worn down. And we can't drill into the earth unless we have a drill to find out what's underneath Vasquez rocks. So what we've got is like the middle of page 7. It's a bunch of rock layers that may have some fossils. I'm not an artist, but I drew what I thought was a dinosaur head, a plant, and then a skeleton of a fish in those layers. Okay, so let's just say that's Vasquez rocks. Now, a great question would be, these are layers that were laid down over time on the earth. So the youngest one should be on top, and the oldest one should be on the bottom. Not that we can guess how long it took them, but if they form one on top of another, it's tough to explain how a bottom one could sneak its way under the pile. So we assume that the bottom one is older and the top one is younger. Now, some people did some work with a high-speed flume in Colorado, where if the water's fast enough, that does not happen. They took videos of this. It's really cool. It's on the web. What happens is a sequence, like 4 or 5 or 6 layers, they form at once, traveling from like one side of the tank to the other side of the tank. And they form layers, and so only when the water's flowing fast and has lots of sediment to it. Right? So it's not necessarily always true that the oldest is on the bottom. It could be in that situation with that flume that the oldest is like to the left or to the right, but that's kind of a minor point though. Okay, so is it possible that those layers could be upside down? Maybe the oldest found its way on top or something. So let me show you how that could be. We have 2 pieces of paper here. We have a red one, a pink one, and a blue one. So let's say the pink one is on top of the blue one. That would make it younger, being on top, younger, and the blue one on the bottom is older. Right? Now, if we could fold these pieces of paper, like folding the rocks, then what's in the middle now, the pink is on the bottom, isn't it, in the middle? Pink's on the bottom, and so it's upside down if you look at the middle of this fold. and that's what I tried to show there on page 7, is that it is possible that rock layers could be turned upside down. Okay, it can. But let's ignore that for now, but I'm just pointing out that that can happen. Okay. Now it's really important at the bottom of page 7 to realize the order of layers implies nothing about the length of time for deposition to occur. Nothing. It's called relative dating. It's like oldest at the bottom, youngest at the top. It's like if you had a bunch of trees that had fallen in the forest, wouldn't the first one that had fallen be underneath all the others? Mm-hmm. Like that. It's the same idea. But it doesn't tell you when they fell. It just gives you an order, right? So my brother gave this to me for my 20th birthday, I guess. It's a book written in 1870 by James Dana. And here, Dana says that the Earth, at this time, 1870, was 300 million years old. I got a typo at the second line from the bottom. The word Wittenberg should have been written, not Wittenberg. So, but this book was written in 1870, and he claims, in fact, he's convinced the Earth is 300 million years old. Because, he says, sand accumulates so much per year. Clay accumulates so much per year. Coral grows so many feet a year. And so he estimates and guesses at all of this, and then he adds up all these layers in a sketch of the Earth's history, and comes up with, well, the Earth must be 300 million years. That's thinking of the past in terms of the present, right? If things are happening in the past as they are now, then maybe the Earth is that old, but that's a huge assumption. Okay. If you were an ordinary, if you were a geologist that is not a creation geologist, you may think that these layers, like Vasquez rocks, would have taken years and years, maybe thousands of years to be laid down. And a creationist would say, gee, if there was a flood, maybe that whole thing could have happened quickly. So it's really a matter of what your presuppositions are as to how long it took. But the sequence of the oldest at the bottom and the youngest at the top is probably a pretty good guess to be so. Okay. So to illustrate what happens next, how are we going to put rock layers together from all over the world? If we had Vasquez rocks, where does that fit into all of the layers that are everywhere on the Earth, right? So to illustrate this, I just love this. I took this book and I tore it apart. It's called The Nature of Geology. So I did this once and I didn't look carefully, and a lady in the class, a student, had a cup of coffee and she threw it in the air when she saw it coming at her and got everybody. I noticed that Bob does not have coffee in his hand. Right, threw it at him. Okay, so now we have the pages out of order. How would you put the book back in the correct order? What would you use? Page numbers, awesome. Let's say you didn't have page numbers. How could you put the book back together? You're going to read it. You got two ways to put it. Okay, so the question with the rocks are, how do we put the sequences relatively together? How do we know what rocks were before Vasquez if we don't see them? And how do we know what rocks were after Vasquez if we don't see them? Maybe they're worn away. Maybe they appear somewhere else, but they're worn away Vasquez rocks. Okay, so here's what's happened. Over 100 and some years, people have looked for the same fossil in different layers. Now, you see, the type of rock is not time dependent. Sandstone can accumulate at any age. I mean, sand is not just old sand. Sand can be young sand, right? And coral can grow a long time ago, or it can grow today. So it's not the kind of rock that tells you the age, but they use fossils. They say, fossil, same fossil. They add them together in the sketch and make a longer sketch. The commonality with matching layers here, all around the world is a common fossil. So if you look at the bottom of page 8, you see a long column of rocks on the right side, but you see those 3 separate sections. If you take your pen or pencil and you draw so that the dinosaur head matches the dinosaur head, draw from left to right, and you'll come to the dinosaur head on the right. What you're doing is you're adding layers based upon a common fossil. So if you have two layers that have the same dinosaur head, you say dinosaur head, same time, we'll put them together. And now we know what happened before the dinosaur head, because now we have a sequence somewhere else that we can see. And you can match other things. I matched just 3 different fossils to give you the idea that if you have location 1, location 2, location 3, and they have common fossils, you match them together, you put them together, and that was done so that the total thickness of all of the layers on the Earth matching by fossils is anywhere from 125 to 200 miles thick total. Right? Okay. The Grand Canyon's only a mile deep, so we're talking here that we don't have all of them in one place, but on paper we do. That's why it's always on paper. It's never a photograph. It's pieced together. Fossil, same time. Okay. Does that make sense? Fossil, same time. Okay. Okay. So we use fossils to match it. Now, who on earth said fossil, same time? I mean, if I were to match fossil, same fossil, clam, same clam, I would think clams grow, they live on the ocean floor. So I'd say clam, same clam, ocean floor. Right? Or dinosaur footprint with claws, right? So it's got toes. Dinosaur footprint, same dinosaur footprint, the land, not the ocean floor, but the land, because I could see a foot there, right? So you would match it in terms of ecosystem if you wanted to, you could. I would think if a flood deposited them, a flood could move them around, I suppose. But if you have things buried basically where they lived, you could say fossil, same ecosystem. But no. Instead of that, now keep in mind that if there was a flood, Noah's flood, all these living things would be there at one time. That's not what evolution says. Evolution says the middle of the page 9, this is the basis of evolution. So I'm going to read this. This is such a great statement of the evolution perspective. Fossil basis for the doctrine of evolution. Once it was understood, look how this starts. This is so cool. Once it was understood that each fossil represents a biologic entity instead of a special divinely created life form. In other words, once we don't believe the Bible, it became quite obvious that plants and animals of each stratigraphic division, that means a series of layers that have something in common, had simply evolved from those of the preceding epoch through gradual adaptation. This is obvious, right? They were in turn ancestral to those that followed. Right? So they have developed the characteristics from their ancestors. A sedimentary rock, therefore, can be no older than the youngest fossil in it. Mm-hmm. So you see how the interpretation is now not same fossil, same ecosystem. It's fossil, same time. Okay? And that is a complete, total assumption. If you're not there to see it alive at that time, and only at that time, you can't do this. You can believe anything you want, but it's totally assumed. And what's just amazing about this, if you turn to page 10, and look at the sketch I have on that page. In order to have a fossil be at a place in that sketch, like a dinosaur, and call it dinosaur age, dinosaur, right? Something had to occur by evolution to get it there. Its ancestors weren't dinosaurs, right? So evolution put it there, and extinction kept it from being buried in younger rocks. So you have evolution that brought it there from the past. Evolution removes it from that point onward. And so what in the classroom, give you a hint, what in the science classroom is pointed out as evidence of this kind of evolution? Molecules to man, fish to philosopher. What do you point to? Do you point to a lab experiment where molecules turned into a fish? Do you point to blue-green algae that in the laboratory turned into a frog? No. You open this up and you say, look on page this of your textbook. There's the evidence for evolution right there. Do you see? This is called circular reasoning. This is not individual. I'm going to demonstrate evolution separately from the sketch. It's you need evolution and extinction to make the sketch, then you use the sketch to convince people it's true. Right? Now, if you look carefully at this is just a rough idea of ecosystems. Down here are things that lived in the ocean, very rough, lived in the ocean and then on land, right? It's not exact, but it's similar, right? In other words, the first living things formed in the oceans, right, at the bottom. And if you're a human and there's a flood coming, I'll guarantee you wouldn't sit there and say, oh, woe is me, I'm going to drown. You would probably go to a high point because it's not wet yet, right? And you would be at the top, right? So it does, and dinosaurs would be, in the age of the dinosaurs. What is the age of the dinosaur? I like to think of it as the ecosystem of a dinosaur. Because not all dinosaurs had feet, some had fins, so their ecosystem would be in the ocean. Okay, so how good is this idea of evolution? Does it make sense? Well, it makes sense until you find something that was extinct and should have been, only in the fossil record, has been found alive. Look at the bottom of page 10. Prior to 1939, rocks containing a coelacanth were supposed to be extinct 70 million years ago, but in 1939, one was found alive off the coast of South America. And so I've got a list of all of these. I love to show these to my students because if something really is supposed to be only in the fossil record, why did it show up as something alive now? If it's alive now, it was never extinct at all, because you wouldn't have it now alive if it was extinct. So I've got on page 11, I've got a bunch of things. A tree that's alive, thought to be extinct 20 million years ago. Some things in the ocean, hundreds of millions of years extinct, but they're not. They were found alive. And then let me just talk about the one called the graptolite, because that's near and dear to my heart. I just love this. When I was a ranger in Yosemite, this guy would come to Yosemite, and he was the chief geologist of this country. His name was Dallas Peck. Chief geologist. No geologist higher than this guy. He would come to Yosemite, stay in the campground. His family was bored stiff for a week because they were left there by themselves. And he would go off on the trails of Yosemite to make his map of the Merced Quadrangle. That was his. He started it when he was in grad school. He had to finish it. That was his thing. So I thought, okay, I'm going to make my days off, because my brother was my boss at the Park Service. So he said, okay, my days off are the days he's going to be there. So I'm going to hang out with this professional geologist, and I'm going to learn from him. He's a great, great guy. He taught me all sorts of crazy things, neat things that are just really precious to me. How did he get his degree? He got his master's degree from Caltech by dating the rocks at Convict Lake. Convict Lake is near Mammoth. Maybe you've been there. Okay, great place to fish. On the opposite side from the lake, from where you pull in and walk up to the lake, there's a cliff, and the cliff has fossils in it, and those fossils are graptolites. He got his master's degree, then went on back east at MIT and got his doctorate. And these things are alive today, found in 1992. And here's my point. If the chief geologist of this country mistakenly thought something was extinct and it's alive, if he can make that mistake, any one of us can make that mistake. Any one of us can make it. I mean, how do you know something is extinct? Don't you have to look everywhere at the same time?
Right.
Is that possible to do? I don't think it's possible. I think you can believe something is extinct, but I don't think you can prove that something is extinct. And for that matter, if this sketch is supposed to be for millions of years, where have these things been that they haven't been fossilized, right, elsewhere? I mean, if they've been alive since they were supposed to have been fossilized, what happened? Why weren't they? And I think the problem is this: when you find one, where do you put it in the sketch? You always put it with the ones like it. You never put it anywhere else. So it always works. And that's, it's really an interesting concept, and you believe what you want to believe, but not necessarily what is true, right? So, yeah. They're called living fossils for a good reason. They're alive. Yeah. Oh, and by the way, that first one called a coelacanth, that was supposed to be the intermediate between a fish and an amphibian, because it has very strange cartilage in its fins, right? So when you fossilize something, you get maybe 10% of the anatomy. Only the hard parts, the soft parts are not fossilized. So before 1939, they only had 10% of the anatomy. Since 1939, they've had 100% of the anatomy. They found 40 some of these things alive. So now that they have all of the anatomy, you know what it's classified as? A fish. And you know why it's a fish? Because it has all the parts to a fish. It's just amazing how how science works. We try to make conclusions with the little bit that we find out, right? Yeah. So there's another one. Archaeopteryx is supposed to be intermediate between I'm going to get to that in just a moment here. Oh yeah, at the top. Look at page 12 at the top. This is amazing. There's an award-winning book out there for children. And I'm sure parents and grandparents have read this to kids many, many times over the years. And it's won awards. And one of the award givers was the American Association for the Advancement of Science, the most involved at promoting evolution group on this planet. And it's called The Wonderful Egg. Why was it so wonderful? Because some people believe evolution is not slow and gradual, but happens in one generation. This most wonderful egg was an egg laid by, all right, as you might guess, a dinosaur, right, because we found dinosaur eggs, and it hatched into, what do you think? If it was the most wonderful egg, what would it hatch into? A bird. That's right. And so this story is all about how a dinosaur egg hatched into a bird. The most wonderful egg ever laid. It won, seriously, it won these awards. Now, and besides that, they even tell you what bird it was, Archaeopteryx. Archaeopteryx is a fossil that's supposed to be intermediate between reptiles and birds because it has some strange parts. Like it's got claws in the middle of its wings, claws. Well, so does the hoots and the taraco and the ostrich, and they're all alive, right? So I mean, that's strange to have claws here, but it's not unusual. And Archaeopteryx has a furcula. Furcula is a wishbone, and the wishbone is the bone that the flight feathers, flight muscles are attached to. So it's probably capable of flying, right? And so it's called a missing link in between. It just may be a strange bird. I don't know. But it has characteristics that are not necessarily unique to anything that's, that it only has. Okay. So on page 12, I have a sketch of the ecosystem matching, right? The Paleozoic means old life, Mesozoic, middle life, and Cenozoic means recent life. And so, you could match them in terms of ecosystem if you want to. I wouldn't fault anybody for doing that. It's, I think, probably a better match than time. As you can see, I've been pretty sarcastic about it. And then after the flood, Psalm 104, verses 5 through 9 talks about how the mountains rose, the valleys sank, and like that. So the rock layers are, after they were deposited, they were broken up and moved around. And I think continental drift happened after the flood, after the layers were laid down like that. That's my opinion. All right. And then if you turn to page 13, you may be wondering, in bold print here, you may be wondering that the process of petrifaction, turning something to stone like petrified wood, would take a long time. And so that would mean that the Earth has to be old. Well, not necessarily so. Despite 45 million years of sitting around, there are some rocks here that, let me show you here an article. Get it out of here. This is an article that says after 45 million years, you would think that the rocks should be turned to stone, but they're not. He said he's going to come back next year with wood saws because they are cut with wood saws. They're flexible, and you'd think, boy, to be 45 million years old, I mean, that should be old enough to be turned to stone. There just wasn't the right conditions to turn it to stone. You need water-carrying minerals in. All right, so that's the first article there. The second one is Mother Shipton's Cave. If you're wondering what the oldest tourist trap is in England, this is it. In the 1600s, they charged people to hang up things in Mother Shipton's Cave to be petrified, to be turned to stone. It says people have hung up sponges and birds and gloves and kerchiefs and veils hunters' caps and foxes and cats and dogs and birds and boots, all to be petrified by the water that comes out of this cave. So the water is charged with minerals to petrify things. And it takes about a month or so to petrify, to turn to stone a cat or a dog, like that. So this is Scientific American, 1889. Right? It's still in business, by the way, and they still charge but more money than they used to for people to go in and see the petrified thing. Then there are people that have been dug up for various reasons that, you guessed it, been turned to stone. And that just has happened over a few years of time. And then there was some wood posts in Australia that the parts of the wood fencing that were underground were turned to stone in about 10 years. And the guy found out how to do it, and now he's in business turning real wood into stone to be used by people that have horses so the horses don't chew their corrals. That's pretty cool. And he can turn wood into stone in a matter of a few days. Right? Okay. So it may or may not take a long time to turn something to stone. Okay. And then the last one here, radiometric dating. This is the dating method that is used to get the age of the Earth in the billions of years with actual measuring a quantity of something. There are radioactive elements called parents that turn naturally into daughter elements. So in that sketch on the bottom of page 13, those circles represent P is parent, D is daughter. And if you wait an amount of time called a half-life, naturally the parent turns into the daughter, but the time we give it is the time for half of it to turn into the daughter. So like uranium to lead, the half-life is 4.5 billion years. So in 4.5 billion years, the 1 pound of uranium you start with would be a half a pound of uranium and a half a pound of the daughter products. Right? So you'll notice that if you go each half-life through those circles, you have less and less parent and more daughter. Right? So uranium turns to lead, and it happens at a fixed rate. And so this is radiometric dating. So turn the page now to page 14, and I start the assumptions of this method. What are we assuming if this is so? Like, if in the rock, the parent that's in the rock is supposed to turn to daughter, what are we assuming that we don't know for sure? Okay. Well, notice the number 1 there on page 14. We have to assume there was no daughter element in the rock when it cooled. This only works for rocks that are cooled off, igneous rocks. They're not sedimentary now with pieces stuck together. This is like volcanic rocks or rocks that cool underground. Okay. So we're talking now about what happened before the geologist grabbed it. Did the geologist really know that there was no daughter to begin with, only parent and no daughter? Right? We have to assume there was no daughter. We have to assume for this to work that all the daughter that's in the rock came from the parent that is in the rock. Okay. Now, how would the rock appear, older or younger, if there was daughter that was there initially? Would it appear too old or too young, do you think? If it came with daughter and the geologist didn't know that and thought that all that daughter was from the parent, would the rock appear too old or too young having daughter initially there with the parent? What do you think? Older would appear too old. Good. Okay. So look at the article that I just inserted here because I forgot it. This is such a great article. This is about a lava flow, and it says it erupted in 1800. It went through Hawaii. I'm looking at the middle now of this separate page. It's a lava flow in Hawaii dated at 1800 to 1801. Why? People had to leave town or die. They know when it was liquid. They know it's on the calendar, and they dated this rock. Now, this is very unusual. You hardly ever pay to date a rock when you already know the age, but they did it anyway. And look at the age they came up with. The rightmost column on those tables is in millions of years. And the highest number there is 2960 million years. That's 2.9 billion years for something, and this article was published in 1968, for something that should only be, how old? 1800 to 1968 is less than 200 years old. Right? Right? This is like telling a lady who weighs 150 pounds that she weighs 15 tons. Right? This is totally off the chart.
You'd only say that once.
This is chart. That's right. I didn't mention what lady it was. Okay. Look at the bottom. These are not dummies. These are scientists that know what's going on. They realize it's too old. But they say at the bottom, therefore, such gases, which means the daughter that it's talking about, such gases represent a portion of the environment in the magma chamber. In other words, before it was burped to the surface, it had daughter in it that made her look too old. Okay? Now, what's really concerning here is that you date rocks that you don't know the age of. You don't date rocks that you do know the age of. So how do you know the age you're getting is correct? Right? This doesn't happen too often that you date a rock that you know the age of. The guy that I shared my desk with at UCLA, he switched to a different doctoral dissertation when he could not date the lava flow at Mammoth Lakes, the lava flow just outside of town, younger at the top but older at the bottom. It came reversed every time he had it done. His professor said, do something else. Because it just doesn't make sense. The data did not show it. Right? The second assumption is that no parent came in the rock, no daughter left the rock. And this is again on page 14. And it's the sketch at the bottom is going to illustrate this. That no parent came in, no daughter left. Because if the rock was altered before the geologist got it, it could appear too old or too young. Like uranium dissolves in water. So does lead dissolve in water. So groundwater can move things through here. Right? So what if parent left the rock and the geologist didn't know? This is point number 2 on page 14. If parent left the rock, wouldn't the rock appear too young? I'm sorry, it would appear too old, because as it gets older, the parent gets less and the daughter gets more. So if parent left, the rock would appear older than it should. What if daughter left the rock? It would appear younger than it should. What if parent entered the rock? It would appear too young, because more parent is younger rock. And if daughter entered the rock, it would appear too old. Right? And what blows me away on this is the sketch at the bottom. This shows the elements that uranium turns into lead, goes through 13 different elements to get from uranium to lead. And it takes 4.5 billion years for half of this to change. Look what I did. I put a box for radon in the middle of that sketch, a little tiny box. Radon. Radon is a radioactive element on its way to becoming lead. It's the second largest cause of lung cancer, second only to cigarette smoking, right? For people that live like you and me on this earth. It leaves the earth, comes into homes, especially back east, and accumulates in the house. And people breathe it, and they have lung cancer. Now tell me this. If it's in the house, it's not in the rock it came from, or it wouldn't be in the house. What does it mean? The earth leaks. So wherever the radon goes, that's where the lead is going to be, and not necessarily in the rock it came from. So have you kept track of all of the radon, where it's gone, and have you kept track of all of it? I think it's pretty clear that is impossible to do. In fact, this is the assumption that is most often put in the literature, is that we really don't know if any daughters went this way or that way. You know, but look at page 15. We're getting near the end here. 15 says something that is amazing. In the Canadian Journal of Earth Science, it says, in conventional interpretation of KAR, which means parent is potassium, that's the K, and AR is the daughter. In the interpretation of potassium argon age data, look at this. It is common to discard ages which are substantially too high or too low compared with the rest of the group and with other available data like the geologic time scale. Oh my goodness, it pops its head up again. So if you get a date of something and it's not reasonable, well, you know the reason why. The daughter moved around. That's obvious. That's like one of my students saying, you know what, I'm going to throw out all my D's and my F's, and I'll keep all my A's and B's, and I'll keep one C, so it looks like everything's fine, and I'll get a grade by throwing out my bad grades. You throw out the ones that you don't like. That's disturbing, isn't it? And then the last assumption at the bottom of page 3 is the half-life has not changed. The time it takes for the parent to turn to the daughter is supposed to be known and does not change. Like a good clock does not tick slow or fast, but it actually keeps constant time. The Encyclopedia Britannica says the half-lives of radioactive elements are immutable, that means unchangeable, under all conditions significant to geology and anthropology. until you look at science journals, like the one on page 16. There's a guy named Otto, and I can't begin to pronounce his last name. They're on page 16. He was searching for a compound. It was tritium, which is radioactive hydrogen, along with lithium. He put them together, and then he heated it to just above the temperature of boiling water. This is not melting a rock here. This is boiling at egg temperature. And he found that the beta decay, which is the indication that radioactive changes are occurring, that are not supposed to change, they fell by 28%. That's like a quarter of the amount. These things are not supposed to happen. In fact, it says there, no process known to physics could account for such a baffling phenomenon. Radioactivity should be unaffected by heat, right? And yet, it changed. And it's not the only article. I just picked one article up from all of these to kind of give you a sense of this. Now, if you've got a fossil at the bottom of page 16, F for the fossil, and you have the X layers, if those are igneous, you could use radiometric dating to date like the layer above the fossil and the layer below. And you can bracket the age of the fossil. That's fine. Or maybe you've got a dike. A dike is molten rock that goes through the earth. It's not the other definition of dike that we won't even mention here tonight. But this dike is molten rock that went through a crack. What if you date that rock in the dike and it's 10 million years old? Doesn't that mean that the fossil had to be there before that molten rock cooled?
Yeah.
Right. So you can do this. I mean, you can combine the dating methods, but all you're doing is trading off assumptions with one or the other, right? It's not that one is, say, without assumptions. They both have assumptions. They all have assumptions. So people do that to get the actual age in years of a fossil. And finally, if you look at the places that do the analysis, this radiometric analysis, that measure the parent and the daughter, they even say, there in the middle of page 17, the New Mexico Geochronology Research Lab writes, certain assumptions must be satisfied before the age of a mineral can be calculated with potassium, which is the parent, and argon, the daughter in this case. Because the potassium-argon dating technique relies on determining the absolute abundances of both argon and potassium, there is not a reliable way to determine if the assumptions are valid. Okay? Now, that's the place that does the work. And I think it's kind of covering all its uncertainties, like, we'll do it for you, but it may not be right. Yeah. And then I'll just mention carbon-14 is one form of this, where all what we are what we eat. Some other carbon we eat is radioactive, it's carbon-14. And when you die, there's a tendency not to eat when you're dead. So all the carbon-14 that you die with is all you get. So the carbon-14 when you die is changing radioactively into other things. And so you can tell how long ago something stopped eating when it died. The problem with carbon-14, it's got 3 more assumptions besides the 3 we've already covered. But it's got so many problems. My favorite quote on carbon-14 says, this is nothing more than 13th century alchemy, and it's amazing that people believe any number of the dates because more than half of them are questionable. And personally, I love this. UCLA publishes a journal called Radiocarbon Journal. They publish the date of some things in an archaeological site in Nevada, and this journal said the date was greater than 100% modern. They published this. And I knew the young lady that was the head of that lab, because it's down the hall from my office, and I was a student at UCLA. So I walked over there and I said, did you really mean to say that it doesn't exist? Because greater than 100% modern means in the future. And she said, well, yeah, we meant to say that. And I said, well, explain this to me. This doesn't make sense. It turns out that in the 1940s, when they tested nuclear weapons in Nevada, in Utah like that, the explosions that they did were underground and it made carbon-14 that blew down, it came out of the ground during those tests and it blew downwind and contaminated a bunch of sites that are archaeological old sites, right? And so there was more carbon-14 than there should have been because of these explosions, right? So they were honest to say, yeah, it's got way too much carbon-14, not too little, but too much because it was contaminated. Right? So all of this to say, that our God, who made the earth, certainly knows exactly how old the earth is, as he was telling Job. Where were you when I laid the earth's foundations? Tell me if you understand. And I, for one, would rather err on the side of using genealogies. That's my personal opinion, because it has a potential of glorifying God, because it's in the Bible and it's God's word more than anything that man has thought of. So that's a long story, a long-winded story to compare the different dating techniques. So, anybody have any questions? Do we have time for questions? I don't even know what time it is.
I'll ask one.
Okay.
Yeah, we have a little bit of time.
Okay.
So, I don't think you have, but, so dinosaurs and men existed together.
Mm-hmm.
So
I think dinosaur, because a man was made on day 6, right? And along with creatures on day 6, right? Right. I think they're made on the same day, weren't they? My brain is so messed up from talking too long.
So you would say that probably they existed before the flood.
Yes. Yeah, like in Job where it talks about behemoth. Yeah, it talks about behemoth as having a tail like a cedar, right? And in the footnotes of many Bibles it says behemoth could be an elephant. Well, you look at the tail of an elephant and it doesn't compare. And then it talks about Leviathan, that Leviathan had its belly had sharp, was as sharp as pot shards. And then the notes in the Bible say it was an alligator or a crocodile. And if you look at both of those, they don't have sharp anything on their tummy. Right? So I think what happens is people think of the most closest animal that's living to match what the Bible says instead of looking at extinct things. Right? Yeah. And in fact, if you look at if you look at dinosaur fossils, and you compare them with the Anglo-Saxon description of dragons, you will be amazed. That's a whole other time we could talk about it, because they are so similar. And in fact, there's a whole branch of science called paleocryptozoology, where people compare actual descriptions of animals that they've seen with the fossils. And there are some amazing similarities, even with things that are in the Bible. Remember the serpents in the wilderness that were like fire? Okay, they're described as like something had something to do with fire. Well, it turns out that the people that were exploring Egypt in the 1600s said, if you see these flying things, play dead, lay on the ground, because if they bite you, it's like you're on fire. Right? And little things like that through history that are really interesting to compare with. So anyway, yeah. In a 6,000-year-old Earth, you have to cram all sorts of things in there, and I do think that dinosaurs and dragons they're just the same thing at different times. Yeah. The dragons are the most recent of the dinosaurs that have not yet died. And the reason why the dinosaurs died is obvious. They're hungry and they take sheep. And all throughout the descriptions of dragons, it's like, well, that one's gone. I praise God for that, and this one's gone. I got to kill this one because I have no more sheep left to raise and feed my family. So, I mean, these dragons had like great appetites, and they just ate the herds of animals that people had. So there was a great reason why they're not around anymore. They were hungry. Yeah. So, good question. Yeah, I do believe they lived together. And in fact, when God says to Job, have you considered Behemoth, who I made like you? Right? Now, he's talking to Job. Have you considered? Job, have you considered something you've never seen before? It existed millions of years before you, but Job, have you considered Behemoth? It just does not make sense. The wording doesn't make sense unless Job knew what God was talking about, right? It doesn't. Yeah.
Same with the Inca stones that have actual pictures of dinosaurs. Those people wouldn't have been drawing anything other than what they saw.
Yeah. You wonder, is that their imagination? No, they probably saw it. And just in case, I'm going to anticipate a question you might have. What is the oldest written record? Because if that's more than the age of the earth, you've got a problem, right? And it turns out if you look on the internet, it's called the Kish, Kish tablet, and it's supposed to be 5,500 years old, if you can believe the dating method that was used to get the dating. But that's less than the 6,000-year-old that we're talking about. So there is no written record that I'm aware of that I could find on the internet that is older than, lots of dinosaurs, but not written record, like a man written record. Yeah. Are y'all convinced the Earth is thousands of years old?
At least.
If God asks you, what would you say? He'll ask that right after he says, "Why should I let you into heaven?" No, I'm making it up. It's not important. It's important that you think of God when you consider the earth, because without acknowledging that He made it, we're not giving Him glory. That's the point. Okay. Okay. Okay.